Hello and good evening, everyone. I hope I'm audible to all of you. So, today we will be talking about Unit 10 Ecology. So, I have taken one session on Unit 10, and today again I will be taking another session on Unit 10. I hope by this time you have revised Unit 10. Yeah. So, yeah, because we are taking daily classes like this. Okay. All right. So at least my rule is the same even for today. So I have some questions this time only, Vikash, from 6 to 7. Okay. All right. To start with, then today's first question. So as we do all the time, okay, I give you a question. You try the question, okay, and then we'll discuss the logic behind the question. All right. So this is, as you can see, it is a graphical based question. Okay. Now this is, I've told you before also, but let me repeat this once again, that ecology is one of the easiest topic in CSIR NET syllabus. It's very easy to understand. And from here you get different kinds of questions like theory based. It can be graphical like this. You can also get some numerical based questions. Okay, so you have to prepare yourself for all the three kinds of questions, and don't get scared by just looking at the graph or the numericals. Most students does that. The questions are very simple. Okay, the graphs are also very simple. If you just analyze it, you will get to know it. So for every kind of question, again, the main mantra is to have a very clear concept. Okay, so in our class, we obviously discuss these graphs, the numerical based questions, and also for those who attend our classes will already know how to solve these kinds of questions. For others, this is your time. Okay. Yes. Good evening, Purnima. So as you can see here, they have shown. So the figure below represents the fundamental and realized niche of two species. Which one of the following options correctly identifies a fundamental niche and realized niche of any one of the species? So this is a question from your fundamental niche and realized niche. So what is your fundamental niche and what is your realized niche? Think about that. And think about how will your fundamental look like graphically and how will your realized look like. Please excuse my throat today. Okay, Devashri is saying two. Others? Okay, Purnima is also saying two. Everyone, please try. I keep telling this every time. Trying is very important. Right and wrong, that is not, this is at least not the place to judge that. Trying is what is important. Okay. So the correct answer here is option 2. All right. So this fundamental niche, no, this Q, this is actually fundamental for both the species. Okay, both the species, this Q is the fundamental. Okay. Now, because both the species, the Q is a fundamental, that means what? They are sharing the same niche, so therefore there will be a lot of competition, right? So to avoid that competition, what the species will do, they will squeeze themselves. Okay, they will restrict themselves only up to a particular portion in their niche. What we call it as a realized niche. So you can take Q as a fundamental niche, and you can take P as a realized niche. Okay, so this is the correct option. Now, if you see here, nowhere else against fundamental Q is given. Okay, so this is the correct option. Okay, another question from Nish. And this is one of my favorite questions from Nish because this truly judges your concept, how much you have understood. So, who's going to give me the answer? Option 2 is the correct answer. Okay, now see, they have clearly told you that followings are the niche characteristics of the constituent species and resource partitioning pattern in different ecosystem. Which of these would lead to competitive exclusion of species? That means here you can see that the different niche, they're overlapping. Okay, the niche of the species, they are overlapping, right? But in this case, as you can see, there is only one shown here, right? That means what? All the species, they have a common niche. So that means the competitive force will be maximum in this case. Okay? Understood? Everyone? Do you agree with me? Do you agree with me? Or you have any doubt? If you have any doubt, clear it out. If not, give me a thumbs up. Come on. Okay. Moving to the next question. Could you explain it again, ma'am? Sure. They are saying that there are many species, right? Niche characteristics of the constituent species and resource partitioning. And you can see that all the niche of all the species, they are overlapping, right? There's a region of overlap. Here also. Okay. So the different niche or the niches, they can be clearly understood that okay, these are the different niches of the different species that is present here, right? Because of this overlap, because of the partitioning, and because of the overlap. But in this case, you get to see only a single graph, right? That means, obviously, since they have said that there are many species, they have given you that hint. This cannot represent just one species. There are many species. Now, when will all the species have a common graph? When all of their niche will be the same and there is no partitioning, you know? So that is why the competitive exclusion will be maximum in this case, because all the niches, they overlap 100%. Now understood? Okay. Moving to the next one. So here you have the list given. Okay. Two communities are here and the different species are here and their abundance is given here. Okay. In their two communities. You have to find out Shannon diversity index. So, do you remember the formula of Shannon diversity index? Yeah. PI. Okay. So you get these questions very often. Okay. You get questions from Shannon diversity index, and next I will do another one. Okay, for those who are new to the Shannon diversity index, I'm giving you the formula. It is written as H prime is equals to summation of I equals to 1 to S pi into ln pi. Okay. So first you have to find out the pi, ln pi, all these things. Okay, Sarita has given me an option 1. For others, you can rearrange the data in this way. Maybe you'll find it easy to do like this. So what is your PI? PI matlab proportionate, right? So 25 out of this is 100. So that will be your 0.25. 0.25 is your PI. 0.25 for each, right? So 0.25 for each. Now, ln of pi. Ln for pi is given here, the ln values. So ln for 0.25 will be minus 1.4. So this is your ln pi minus 1.4. Okay. Now there is a summation of pi into ln pi. So first you have to find out this term. Pi into ln pi. So in another column, find out what is pi into ln pi. So that will be 0.25 into 1.4. 0.35, right? Now I don't have space here to write, but this is your 0.35 for all. This is pi into ln pi. Okay. Now what you have to do? There is a summation. So summation of pi into ln pi. So 0.35 plus 0.35 plus 0.35 plus 0.35, or you can do 0.35 into 4. Okay. So you get 1.4. This is the result of the first one, C1. Okay. In a similar manner, will you be able to do find out C2? Everyone understood? Yeah? Come on, tell me something. Is it understood? So you take each thing at a time, okay? You take this is your PI, then you have taken ln PI, okay? Then you do PI into ln PI, this part, and then you do a summation, okay? Now, if you do this, I'm erasing all of it. Fine. You will see the answer is option 1. Okay, you can try it out for C2 also in the same manner. You will see you're getting 0.69. Okay, so this is your PI values for ABCD, and ln is obviously provided here. 0. 0.8, 0.1, 0.05. All right, you can solve it yourself. Okay, now going for question number 4, which is a question from your population ecology. Okay, so it is saying that in a research on population dynamics of beetles, one student estimate that the population size is 3000 over the course of a month. He records 400 births and 150 deaths in the population. Estimate intrinsic rate of natural increase and calculate what the population size is predicted to be in 6 months. So, what do you think will be the answer of this? So, so what should be your answer to this? Are you doing it? Okay, so let me do this. So what they have said is there are 400 birth, right? 400 birth and 150 death. This is what they have told you. Okay. So after, and there is no migration. So after 1 month, population will be how much? Your initial population was 3,000, right? It was 3,000. So it will be 3,000 plus 400 minus 150. Okay. So the answer will be after 1 month, it is 3250. Okay. Now, R is known as the intrinsic growth rate. Okay. So this rate is what? ln nt plus 1. You just have to rewrite this thing. Okay. By nt. Uh-oh. By nt. All right. So now if you do this, this will come as ln equals to, sorry, it will be ln into 3250 divided by 3000, because your nt, the population at time t was 0, right? Now population of time t plus 1 month, that is your 3250. Now you just have to solve the values. If you solve the value, you will see you're getting r is equals to ln into 1.0833, or you will get the value as r is equals to 0.0800. Okay. Now you have got the value of r. So therefore, you have to place this r value in the proper birth growth rate equation. So growth rate equation says that nt is equals to n0 e to the power of rt. Okay. Now you just put the values. Your n0, you know it is 3000. Your e is there, and r you have already found out. T is given as your 6 months. Okay. So if you take natural log on two sides, you will be able to resolve the e also. Okay, so you will get the value as 4848. Okay, so the closest value that you have here is obviously 1. Okay, so I'll just erase the calculation. So the correct answer here is option 1. All right, now moving over to question number 5. Question number 5, this is, if you see, they have given you following table shows the number of individuals of 5 tree species in a community. Based on the above, the Simpson diversity index is what? So you have to know the formula of Simpson diversity index. What's the formula of Simpson diversity index? Who can tell me? Have you studied these parts? Why am I not getting any answers today? So what is the formula? Who can tell me? Pi square, yeah, pi square for each, right? So it is actually summation of n by capital N whole square, right? Yeah, so n by capital N is what? It is actually the pi. In the last, if I draw the similarity with the Simpson Shannon index, then pi was actually that individual divided by total, or relative abundance, basically. Okay, abundance divided by the total abundance is gives you the relative abundance. So this is actually relative abundance square. Okay, so can you now do it? So for each of this you have to find out n by capital N. So this will be 50 by 100, isn't it? What is the total? 50 plus 20 plus 20 plus 10, 100 whole square. So that means for this one it is zero point 0.5 whole square. That means 0.25, isn't it? So this is your 0.25. So like that way you find out for each one of it and then do a summation quickly. Are you being able to follow? Okay. Saritha is saying option 2. Others, are you being able to follow? So you find out for each and then you do a summation. The correct answer is option 2. Everyone, let me know. Okay, Devashri has also been able to do very good. Others, shall I proceed to the next one? Please let me know in the comment section. Okay, so it seems that others are already doing the calculation. Fine, I'll just proceed. You do it at your pace. Now coming to a theoretical question, but yeah, there is a graph shown here. So they are saying that following is a diagram of three idealized survivorship curve of animals. So we know that there are three survivorship curves, right? Type 1, type 2, and type 3. And we know the characteristics of the different types and some examples of the different types also, right? Now you have to match the different types with the examples that is given here. Now this is very easy. This is very easy. Even if you don't remember all the examples that you have studied, because see, in your book they will give you one set of examples, right? In your question they can give you another set of examples, because for one particular concept there can be many examples and it's not possible to memorize all the examples. Okay, but you have to just memorize the characteristic behind it. Okay, so Sarita and Devashri is saying option 1. Others? The correct answer here is option 1. So we know one thing for sure, that type 1 is always for the mammals. Isn't it? The large mammals, it will always be the large mammals. Now just see in which options, even if you don't know what will be happen to the pelagic fish and all, just see type 1 mammal is only given in option 1. Large mammals, type 1. So even with your closed eyes, you can select option 1. You don't even have to bother about the pelagic fish, because nowhere else in the options they have given you large mammal as your type 1. Okay, so these are the hints that you have to catch. Okay, moving on to another question from your population ecology, and this is from your life table. So there are formulas to calculate LX, NX, MX, and all. Those who have studied this in my class, you will be knowing about this. Others, if you have read, then also you will be able to tell me the answer of this. So what, do you know how to do these questions? So you have to do a bit of back calculations here. Okay, they have given you lx dx, sorry, nx dx lx mx. Okay, and they have given you r0. You have to find out r0, net reproductive rate. Net reproductive rate, r0 formula is summation of lx into mx. Exactly. Okay, not just lx into mx, summation of lx into mx is the r0. So you have to, so mx is given to you, that's fine, but you have to find out the lx as well, right? To find out lx you have to find out the dx, nx and all these. So you have to do a bit of back calculation here. Wherever you can start the calculation, start from there. And I feel the best place to start is by looking into these two columns, because this is a pure subtraction. Okay, subtraction and addition. So nx is number alive, number dying. Okay, the remaining will be moving to the next generation. That is the logic. Like 100 minus 50 is the 50 in the next generation. Okay, now 50 minus something is again something. So you can't solve two unknowns together. So look into the next one. Something minus 10 is 20. Okay, so something minus 10 is 20. That means this something has to be 30. 30 minus 10 will be 20, isn't it? So you just have to add 20 plus 10 to get this something. Okay, similarly 20 minus 10 will be how much? 10. And over here 30, 50 minus something is 30, so obviously this is your 20. 50 minus 20 is 30, right? See, the very school level mathematics this is, in fact the primary section mathematics, right? So now you have got the values for your nx and dx. Now can you find out lx? What's the formula of lx? It is nx by n0. Okay, it is nx by n0. So what is n0? It is 100. Okay, so 100 upon 100 is 1. 50 upon 100 is zero point 0.5. 30 upon 100 is zero point 0.3. Okay, 20 upon 100 is 0.2, 10 upon 100 is 0.1. Okay, all right, now see. Okay, so now what you do is you do lx into mx. For each one of this, you find out lx into mx, and then you do a summation. Then you do a summation of the lx into mx. So like for so this is 0, this is your 0.25, right? So 0.15, like that way you find out. Okay, Sarita is saying option 3. The answer is option 3. Was it very difficult? I don't think it was very difficult, right? You just have to know the trick, the logic, and the formulas, of course. Everyone got that? Sorry, this is your point 2, and this is your point 1. Yeah, sorry. Now you will get. Right? Now everyone got this? Okay, next question. This is about invasive species. What should be the answer here? Got the answer? The answer is option 3. Absolutely correct. Okay, so invasive species in general grow very well in new area that they invade and often outcompete native species. An explanation for the better growth and propagation of invasive species in comparison to their native counterpart is provided by which one of the following hypotheses. Okay, it is enemy release hypothesis. Next, so this is a question from unit 10 only, part 1, part A. Okay, so given below is a list of natural disturbances. All right, which one of the following combinations of disturbances can be contributed to global warming? So the answer to this question is option 2. Okay, chloral bleaching obviously happens because of change in pH. Rising sea levels, that is also a result of obviously global warming. And then you have shift in species distribution, that is also global warming. Okay, so actually this is I would say more specifically this is from your applied ecology, that part. Okay, now this question is from your community disturbances. So they have given you some graphs. Okay, they have given you some graphs here, and you have to match the graph with the current kind of correct kind of representations. So which graph is showing redundancy, which is your idiosyncratic, which is showing rivet, which is keystone. So for this you have to know what are the meanings of redundancy, keystone, rivet, idiosyncratic. Okay, so this comes from your community dynamics, that part, or community stability, more specifically, community stability. Okay, Sarita is saying option three. Wow, very quick. Others? So basically, what is redundancy? Okay, I'll just explain the words to you. Maybe then you will be able to match it. So redundancy is saying that, see, every species has a contribution in the ecosystem function. Okay, so redundancy says that if you keep adding the number, if you keep adding species, that means keep increasing the species number, your ecosystem function will increase up to a point, and then it will level off. So beyond that point, no matter how much or how many species you add, your ecosystem functionality will not change. Okay, that is redundancy. Keystone is, in a community there can be many animals, but one animals, because, or one particular species, okay, because of its role or position, okay, or its function in the community, can dominate the community, can give structure to the community. You can have many species, okay, but when you add this particular species, a keystone species, then you will see a sudden change in the ecosystem function, because the presence of the species itself makes a huge difference. That is keystone. Idiosyncratic means there is no connection between addition of species and ecosystem function. So at times you can see that with addition of species, your ecosystem function is increasing. At other times you will see a reverse case is happening. Okay, there is no similarity. There is no connection between the two. And last we have the rivet. Rivet says that each and every species has a contribution in some way or the other. It can be small or big, but there is always a contribution of that species, some contribution of the species. If the species contribution is small, then if you remove that species, not that impact will happen on the ecosystem function. But if the contribution is very high, then if you remove that species, then that will make a Okay, so I have two questions with me now. This is a question from population distribution. Okay, this is a question from population distribution. I want all of you to try this question. Everyone try this question. So basically, the answer to this question is option 1. How do you do it? Just remember these formulas. Variance by means. Okay? So variance 5.05 divided by mean 5.3 if you do. All right? If you see the value, if it is coming more than 1 or less than 1 or equal to 1, then you draw a conclusion. So like in this case, you have 5.05 divided by 5.3, you get zero point 0.9, right? So zero point 0.9 is less than 1. So that means it is even or uniform distribution. Okay, so this is showing you uniform distribution. Like that way, you do 0.35 by 7.05. Here also see, you will see that it is coming less than 1. So that means uniform distribution. For the next one, if you do 50.5 divided by 5.3, you will see you will get a value which is greater than 1. Okay? So if the value comes greater than 1, then it is your clumped distribution. Clear? So this is again another kind of question. And the last question for today. The last question, this is from your uh, facilitation model, tolerance model, which comes in your chapter succession. Okay, so you have to study about the different models. How, what is the meaning of inhibition model? What is the meaning of tolerance model? What is the meaning of facilitation model? What happens over there? Okay, so when you study the chapter succession, you have to study this part also. You get theoretical question like this in statement basis, or you can also get it in a graphical way. Okay, you get questions from here. So as we know that in this case the answer is option 3. So they are telling you that which is the correct option. So in inhibition model, strong competitive interaction is present as no species is completely superior. Okay, just a competitive interaction is present. So like whoever gets a chance to occupy a place becomes superior. It's not that the others are not superior. This species could colonize first, so it has become dominating over there. Okay, and next, intolerance model, later successional species are inhibited nor aided by species of previous stages. Okay, that is tolerance model. So anyone can come and colonize. If you find the area suitable for your colonization, you can colonize yourself and expand your population. The others will have a lower number of population in their population. Again, when the others find a place which is suitable for them, they will go and colonize that area and they will become dominant over there. Okay, so it is like neither is inhibited nor aided by the previous one. ठीक है? So this is all that I had to discuss. Now, what you can do is you can go to our app and attempt the T3 test series. You have some 10 questions over there, okay, with answers. So practice more to score more. For those who wish to join us, you can definitely reach us or inquire with us in this toll free number. So, thank you and wishing you all the best.